Welcome back to Maths with Mrs. J. I'm going to start a series of videos about solving equations simultaneously. What that means is that you want to find the values that will satisfy both equations. Probably the easiest way to introduce this topic is to show you graphically what's happening. So for example, say I was asked to solve these two equations simultaneously. The first equation is 2x plus 3y is 24, and I'm calling that equation 1, and I'm doing that graph in orange. And the second one, x minus 3y equals 3, I'm calling that equation 2 and colour coding that in green. So what does that mean if 2x plus 3y equals 24? Well, that line consists of an infinite number of points, all of which the x value times 2 plus the y value times 3 is equal to 24. Infinite number of points along that line, and all of them satisfy that equation. If we wanted to sketch that straight line, probably the quickest way to sketch it is x and y intercepts. X-intercept occurs when y is 0, so we get x as 12. Your y-intercept occurs when x is 0 and we get y as 8. So that's why I drew that orange line there. Now, our green line has an x-intercept of 3 and a y-intercept of -1. And it too consists of an infinite number of points that satisfy that equation. So the x value minus 3 times the y value equals 3. In order to find a simultaneous equation, we want to find the x and y values that satisfy both. Now, if we have two linear equations, then clearly they can only cross at one point. There are occasions when they won't cross at all. They might either completely coincide, in which case they're the same line, in which case there's an infinite number of solutions, or they might be parallel lines and never meet, in which case there is no simultaneous solution. But the usual way, if you have two straight lines, two linear functions, is to get one simultaneous solution. And reading this one off here, we can see that we've got an x value of 9 and a y value of 2. Let's just check by subbing into both of these equations that that is in fact a solution to both of them. So in equation 1, if we do 2 times 9 plus 3 times 2, what do we get? We get 18 plus 6. Yes, that is 24. So yes, equation 1 is definitely satisfied. And if we sub that into equation 2, we get 9 minus 3 times 2, which is 9 minus 6, which is 3. So yes, equation 2 is also satisfied. So one method that you can actually use to solve equations simultaneously is to graph them and read off the point of intersection. If you happen to have something other than two linear functions, you might have a parabola and a linear function, it's quite possible that you might have more than one simultaneous solution. That's perfectly fine. I'm going to start teaching you over these videos the various ways other than graphing to do it, because graphing obviously has its limitations as far as accuracy is concerned. And it can also be a little bit time consuming. I'm going to teach you two algebraic methods to solve equations simultaneously. One of them is called elimination, which to eliminate something means to get rid of. So it literally means that you're going to add or subtract equations to get rid of one of your variables and go from there. The other way is substitution, which is when you write one in terms of the other and sub it into the other equation and go that way. So stay tuned for the next few videos and I'll teach you how to solve these ones with both of those methods.